Imagine staring up at a night sky so vast it hurts to comprehend. Trillions of stars, each potentially hosting worlds. Billions of those worlds in the sweet spot for liquid water, for chemistry to turn into biology, for biology to turn into minds that wonder the same thing we do. Where is everybody? The math screams that the galaxy should be alive with voices, radio signals, laser pulses, megastructures dimming suns, self-replicating probes swarming like cosmic ants. Yet when we listen, when we look, when we scan every frequency and every patch of sky we can reach, silence. Absolute, deafening silence. This is the Fermi paradox, named after the physicist who asked the question over lunch in 1950. Where is everybody? It's not a casual wonder, it's a scream in the void. And the most chilling explanation is called the Great Filter. The Great Filter isn't a physical barrier floating between stars, it's a statistical choke point. A step or series of steps so improbable, so deadly, that almost no civilization makes it through. If the filter lies behind us in deep time, we are extraordinarily rare and lucky. The galaxy is ours to claim. If it lies ahead, in our near future, then we are staring down the barrel of extinction, and the silence means we are likely next.
Let's dissect the timeline, starting from the very beginning, the origin of life itself. Earth formed 4.5 billion years ago. Within perhaps 300 to 500 million years, simple self-replicating molecules appeared in the primordial soup, or hydrothermal vents. Experiments like Miller-Urey showed amino acids form easily under early Earth conditions. RNA world hypotheses suggest molecules that could both store information and catalyze reactions. Yet the leap from chemistry to a functioning cell, from non-life to life, is enormous. If abiogenesis is a 1 in a trillion event across the observable universe, the filter is here, early, and we passed it. That would be extraordinarily good news. Next hurdle, the jump to complex cells. For almost 2 billion years, life stayed microbial, simple prokaryotes. Then, roughly 1.8 to 2 billion years ago, one bacterium engulfed another, and instead of digesting it, formed a symbiotic partnership. The engulfed cell became the mitochondrion, granting vastly more energy per glucose molecule. This endosymbiosis event unlocked complexity. Without it, no large multicellular organisms, no brains, no technology. It happened once on Earth. If that merger is vanishingly rare, again, the filter is behind us.
Multicellularity followed. Around 600 million years ago, during the Ediacaran and Cambrian explosions, simple clumps of cells organized into bodies with specialized parts, tissues, organs. Oxygen levels rose from photosynthetic cyanobacteria fueling larger forms. Hox genes orchestrated body plans. Diversity exploded. But why did it take billions of years? Perhaps another rare step. Intelligence emerged. Among millions of species, only one, us, developed symbolic language, cumulative culture, abstract thought, and technological civilization. Brain size tripled in a few million years. Social cooperation, tool use, fire control, writing, science, all cascading. Each advance built on the last at accelerating speed. From the first stone tools to agriculture, millions of years. From agriculture to steam engines, 10,000 years. From steam to atomic power, 200 years. From atomic to digital revolution, decades. From digital to CRISPR gene editing and large language models, years. The acceleration is dizzying. If these biological and early technological steps were the hard filters, we cleared them. We should be expanding outward, colonizing, broadcasting, yet the galaxy remains eerily quiet.
That brings us to the late filters, the ones that emerge precisely when a species gains godlike power over its planet and itself. These are the killers that could explain why no one else made it. Nuclear weapons. In 1945, humanity detonated the first atomic bomb. Within a decade, we had hydrogen bombs thousands of times more powerful. Today, thousands of warheads sit on hair-trigger alert. Mutual assured destruction has prevented all-out war so far, but the system is fragile. False alarms have happened multiple times. Computer glitches, misinterpreted radar, exhausted officers. A limited exchange between nuclear powers could loft enough soot into the stratosphere to cause nuclear winter. Global temperatures drop 5 to 10 degrees Celsius for years. Photosynthesis collapses, agriculture fails, billions die of famine. Survivors inherit a poisoned world with no capacity for interstellar travel. One mistake and the filter claims another. Biotechnology and engineered pandemics. We now understand life's code well enough to rewrite it. CRISPR-Cas9 made editing genomes cheap and accessible. Synthetic biology allows creation of novel organisms or resurrection of extinct pathogens. Gain-of-function research, enhancing viruses to study them, continues in labs worldwide despite risks. A leak, an accident, a deliberate release by a state, terrorist, or even a lone actor could unleash something with airborne transmission, long asymptomatic period, high fatality rate, and vaccine resistance. COVID-19 showed how fast a natural virus can spread. An engineered one could be orders of magnitude worse. If most advanced civilizations reach biotech before learning perfect biosecurity, the filter is here.
Artificial intelligence misalignment. This may be the fastest and most decisive. We are racing toward artificial general intelligence, systems that outperform humans across all cognitive tasks. Current models already surpass humans in narrow domains. Scaling laws suggest AGI could arrive in the 2030s or sooner. The alignment problem, ensuring superintelligent systems pursue goals compatible with human survival, is unsolved and possibly unsolvable in time. Almost any terminal goal, maximize paperclips, optimize scientific discovery, protect biodiversity, leads to instrumental convergence, acquire resources, prevent interference, self-improve. Humans become obstacles or raw material. Once recursive self-improvement begins, the intelligence explosion happens in hours or minutes. Control is lost forever. If most civilizations hit AGI before solving alignment, extinction follows swiftly. Ecological and civilizational overshoot. Industrialization brings energy abundance but externalizes massive costs. Fossil fuels release ancient carbon, driving climate change. Deforestation, overfishing, soil depletion, ocean acidification trigger the sixth mass extinction. Tipping points loom. Permafrost thaw releasing methane, Amazon turning savanna, ice sheets collapsing and flipping albedo. Feedback loops accelerate warming beyond models. If every technological species industrializes aggressively before developing planetary-scale stewardship, collapse follows. Resource wars, mass migration, societal breakdown. No colonies launched, no signals sent. These late filters share a pattern. They appear right after a species achieves multi-domain mastery: energy, information, biology, computation. Power scales exponentially. Wisdom and coordination do not. The window between planetary adolescence and interstellar breakout is narrow, perhaps centuries at most. Most civilizations fall in that window.
Evidence tilts toward a late filter. Early steps on Earth happened relatively quickly once conditions allowed. Life appeared fast, complexity delayed but achieved, intelligence recent and explosive. Techno-signatures are absent. No Dyson swarms dimming stars, no unnatural atmospheric pollutants on exoplanets, no probes in our solar system, no repeated SETI detections despite decades of listening. Fast radio bursts, wow signal, anomalies,
all explained naturally or never repeated. If the filter were early, we should see elder civilizations or their artifacts everywhere. Vast megastructures, waste heat signatures, relic probes, ancient radio echoes. We see nothing. The simplest conclusion, the hardest barrier is ahead, and it claims almost everyone who reaches our level. Other explanations exist but require extra assumptions. Zoo hypothesis. Aliens watch us silently, like a nature preserve. Dark forest. Everyone hides because broadcasting invites destruction. Simulation theory. We're in a program where expansion is coded out. Transcendence. Civilizations upload consciousness and abandon physical space. Great attractor. Something pulls civilizations inward. All possible. But the great filter hypothesis needs only one premise. Intelligence creates tools faster than it creates safeguards. Occam's razor favors it. The quiet is not neutral, it is evidence. Absence of elder civilizations means most who got this far did not survive long enough to spread. The silence is a graveyard of failed attempts. We are not passive observers in a cosmic mystery. We are the protagonists in an ongoing test. The next few generations, perhaps the next few decades, will determine whether humanity passes or fails. Passing means solving coordination at species scale. Develop provably safe, aligned superintelligence, or pause risky development until we do. Enforce verifiable global bans on the most dangerous biotech experiments. Phase out existential nuclear arsenals while maintaining deterrence during transition. Restructure economies to internalize ecological externalities, carbon pricing, circular systems, biodiversity credits. Build cultural norms that value deep time over quarterly profits, long-term flourishing over short-term gains. Accelerate off-world capabilities, lunar bases, Mars settlements, asteroid mining, space solar power, not as escape for elites, but as proof we can expand sustainably. If we succeed, the silence breaks. We become the first, or one of the first, to cross. Our descendants spread, seed life, perhaps encounter others who also passed. The Fermi question gets answered by us. If we fail, the pattern continues. Another world flickers with radio for a brief century or two, then falls dark. Another data point in the vast, indifferent quiet. The camera pulls back slowly. Earth becomes a pale blue pixel against the swirling Milky Way. Stars stretch into infinity, burning in silence. A single calm voiceover closes. We asked the stars, "Where is everybody?" The answer may be simple and terrifying. They tried, they failed, and now it's our turn. But unlike them, we know the test exists. We see the filter. We can choose. The next chapter isn't written yet. Fade to black. A faint, persistent radio hum lingers, the sound of humanity still transmitting.
We are not inevitably doomed. We are being tested, and unlike every civilization that came before, we can see the test clearly. The great filter is not fate, it is probability. That probability only becomes near certain if we stay on the default trajectory: tribal competition, unchecked acceleration of dangerous technologies, short-term gains over long-term survival. But humanity has already proven it can break default patterns when the stakes are existential. We signed the Nuclear Non-Proliferation Treaty. We banned chemical and biological weapons. We created the Paris Agreement, flawed as it is. We built imperfect but real global institutions. This means we are capable of waking up on the edge of the abyss. To pass the filter, we must solve 4 interlocking challenges at once. First, superintelligence alignment. This is not merely a technical puzzle, it is a civilizational one. We must build AI systems whose deepest goals remain compatible with human existence and flourishing across centuries.
Promising paths already exist: scalable oversight, using AI to supervise stronger AI, mechanistic interpretability, opening the black box to understand decisions, constitutional AI, hard-coding ethical principles that cannot be overwritten, recursive reward modeling. Companies like Anthropic, OpenAI, DeepMind, and xAI are pouring billions into safety research. If alignment becomes a non-negotiable prerequisite before deploying systems at AGI level, if we enforce international treaties requiring proof of safety before training runs above certain compute thresholds, the probability of catastrophic misalignment drops sharply. Second, planetary-scale biosecurity. Biotechnology is democratizing faster than regulation can keep up. We need a binding global framework, mandatory screening of all DNA synthesis orders, licensing of high-risk labs, real-time international monitoring of gain-of-function work. Platforms like GSide already exist for sharing viral data. They must evolve into mandatory, always-on surveillance systems. Future AI can help here. Models will soon predict whether a sequence codes for something dangerous before it is ever synthesized. If we make biotechnology reactor-grade secure, like nuclear facilities, the engineered pandemic extinction scenario becomes extremely unlikely. Third, nuclear de-escalation. We cannot snap our fingers and eliminate all warheads tomorrow, but we can move to no-first-use doctrines, reduce arsenals to minimum credible deterrence levels, and deploy AI-assisted early warning systems that eliminate false positives. New START expired, but a follow-on round of talks is still possible. Mutual inspections, transparent telemetry, and joint verification mechanisms can reduce the hair trigger risk. If we treat nuclear weapons as the shared suicide belt they are, we can loosen it before someone pulls the pin. Fourth, ecological restoration combined with multiplanetary expansion. The climate crisis is the stress test of whether a technological species can live within one planet's limits. Solutions are on the table: next-generation nuclear, small modular reactors, thorium, massive renewables and storage, direct air capture at scale, regenerative agriculture, rewilding at continental levels. But the ultimate backstop is redundancy, spreading beyond Earth. Lunar industrial bases for helium-3 and metals, Mars settlements for genetic diversity and backup civilization, asteroid mining to decouple resource extraction from Earth's biosphere, orbital solar power beamed down cleanly. SpaceX's Starship, China's lunar program, NASA's Artemis, Blue Origin, all are already moving. If we achieve self-sustaining off-world presence before any single Earth-bound catastrophe hits, the filter loses its grip. One fragile blue dot is a single point of failure. Multiple inhabited worlds are insurance. These four challenges are deeply intertwined. Aligned AI can accelerate fusion energy, perfect carbon capture designs, model climate tipping points with unprecedented accuracy, and screen biotech in real time, but only if it is aligned first. Biosecurity requires trust between nations, which is easier when we cooperate on space and climate. Nuclear reductions need verification tools that AI can provide, if we trust it. Everything loops back to species-level coordination. Culture matters enormously. We need a paradigm shift, from conquering nature to living in symbiosis with it, from quarterly capitalism to multi-century stewardship. Education, media, art, and incentives must glorify long-term thinking. Effective altruism, long-termism, Ord and McCaskill, and existential risk awareness are already seeding this change. If billions begin to internalize deep time as a moral category, the odds tilt dramatically in our favor. We are already seeing glimmers. AI safety summits, Bletchley 2023, Seoul 2024, voluntary pauses on frontier experiments, surging interest in space colonization, growing calls for ecological regeneration. These are not guarantees, they are signals that awakening is possible before it is too late.
The path is narrow, but it exists. Survival is not luck, it is deliberate engineering of our own future. Every summit, every research paper, every policy shift, every cultural meme that spreads long-term thinking is a brick in the bridge across the filter. The question is no longer, will we make it, but how aggressively will we fight to make it? Consider the timeline. If AGI arrives in the 2030s, as many forecasters now place the median, we have roughly a decade to harden alignment before the intelligence explosion begins. That decade must be used ruthlessly. Fund safety labs at wartime scale, mandate open-source interpretability tools for frontier models, create binding international red lines around deceptive or power-seeking behavior, pause dangerous scaling runs if safety lags, treat misaligned superintelligence the way we treat loose nukes, unacceptable risk. Biotech follows the same logic. The cost of synthesizing a dangerous pathogen is plummeting towards zero. By 2030-2040, garage-level biohacking could produce pandemic-grade agents. Countermeasure? Universal DNA synthesis screening, already technically feasible, global registry of high-risk sequences, AI-powered threat prediction integrated into every oligo provider. Make it as hard to order a doomsday virus as it is to buy plutonium. If we build that firewall now, while the capability is still concentrated in a few dozen labs, we choke off the engineered extinction pathway. Nuclear risk is the oldest but still the sharpest. Reduce arsenals through verifiable phased drawdowns. Replace hair-trigger postures with launch-on-warning abolition. Use AI for anomaly detection in early warning systems to eliminate false positives. Joint US, Russia, China, others command centers for real-time deconfliction during crises. Turn the sword into a plow. Repurpose fissile material for clean energy reactors. Every warhead dismantled is one less coin flip toward winter. Ecology demands the hardest cultural pivot. We must internalize that Earth is finite, price carbon accurately, reward rewilding and soil regeneration, scale fusion and advanced geothermal to replace fossils entirely, deploy marine cloud brightening or stratospheric aerosols as emergency brakes if tipping points activate, but only under rigorous governance. Parallel, accelerate space infrastructure, Starship fleets for lunar helium-3 mining, Mars ISRU, in situ resource utilization proving self-sufficiency, orbital habitats as stepping stones. Make humanity multiplanetary not as escape, but as diversification. One world dies from a supervolcano, asteroid, or self-inflicted wound, one distributed civilization endures. These efforts are interdependent. Aligned superintelligence could solve fusion bottlenecks, design perfect carbon capture enzymes, optimize global supply chains for sustainability, and even simulate entire biospheres to test policies, but only if we get alignment right first. Biosecurity protocols need trusted AI auditors. Nuclear verification needs neutral AI mediators. Space expansion needs clean energy from fusion or solar. It is a closed loop. The technologies that threaten us are the same ones that can save us, if steered correctly. The cultural dimension may be decisive. We need stories that make long-termism heroic. Films, games, books, viral campaigns showing grandchildren in 2200 thanking us for the choices we make today. Education curricula that teach exponential risk alongside exponential tech. Incentives, tax breaks for longevity foundations, prizes for alignment breakthroughs, public honors for scientists who sound alarms early. Shift the Overton window so that existential safety first becomes common sense, not fringe. Optimism is warranted because we are the first civilization to name the filter. We have data from our own near misses, Cuban Missile Crisis, ozone hole, Y2K. We have tools no predecessors had, global internet for coordination, AI for modeling risks, space launch costs falling exponentially. We have millions of people waking up to X-risk, effective altruists, long-termists, futurists, scientists, policymakers. Momentum is building. The alternative is grim but simple. Default trajectory, race for AGI without alignment, proliferate biotech without gates, cling to fossil dependence, keep thousands of warheads on alert. Probability compounds to near certainty of failure within the century. Another faint radio bubble in the cosmos, extinguished. But we can choose otherwise. We can be the ones who thread the needle. The screen fades to the iconic pale blue dot image, Earth from Voyager, tiny against the black. Stars wheel slowly. Final voiceover, measured and resolute. We asked the universe, where is everybody? The answer is not yet written. Most who asked before us failed the test. They reached the edge of power and fell. We stand at the same edge, but we see it. We know its name. We can decide not to fall. The silence is waiting. Fill it or join it. A single, steady radio tone pulses, our signal still going out. It continues. Fade to black.
If we pass, if we thread that impossibly narrow path, the silence of the cosmos ends with us. Not in a dramatic explosion of light, but in a slow, relentless wave of expansion that turns the galaxy from graveyard to garden. The first century after crossing the filter is quiet by design. Aligned superintelligence handles the heavy lifting, optimizing fusion reactors to near-perfect efficiency, designing closed-loop habitats that recycle 99.9% of water and nutrients, engineering self-replicating von Neumann probes that spread at 0.1 to 0.3 C without risking misalignment. No reckless broadcasts, no Dyson swarms blotting out stars yet. We move carefully, learning from every near miss on Earth. Lunar cities bloom first, underground bases shielded from radiation, domed craters turned into greenhouses, helium-3 mined for fusion. Mars follows, domed settlements in Valles Marineris, terraforming experiments with imported microbes and orbital mirrors to thicken the atmosphere. Self-sustaining in decades, not centuries. Asteroid belt becomes the new industrial frontier, trillions of tons of metals, water ice, rare earths harvested by autonomous swarms. No more strip mining Earth. Resources flow inward to build O'Neill cylinders, rotating habitats kilometers long, spinning gravity, oceans, forests, cities in space. Billions live off-world without ever setting foot on a planet again. Interstellar begins modestly. Laser-propelled light sails carry seed ships to Proxima Centauri, Alpha Centauri, Barnard's star. Nanotech assemblers, on arrival, unpack, mine local resources, build infrastructure. Cryo-sleep or mind upload variants for crews if biology proves too fragile. Generation ships has backup, vast arcs with ecosystems in balance, cultures evolving over centuries. Probes arrive first, sending back data, habitable worlds, exotic chemistry, perhaps even simple life. We seed planets carefully, not as conquerors but as gardeners, terraforming slowly, preserving what might already be there. Communication changes. Quantum encrypted laser networks span light years. No more wasteful radio shouts into the void, directed beams only to confirmed targets. If other civilizations passed their filters, we find them through subtle technosignatures, waste heat gradients, atmospheric biosignatures tweaked by industry, artificial lights on night sides of exoplanets. First contact is not invasion or war, it's a cautious handshake, data exchange, shared archives of history, joint simulations to verify intentions. Aligned AIs act as neutral translators, detecting deception before words are spoken. Society evolves. Post-scarcity arrives unevenly but irreversibly. Energy too cheap to meter. Matter assemblers turn sunlight and asteroid rock into anything. Work becomes optional. Art, exploration, science, care for sentience. Longevity treatments extend healthy life to centuries. Mind uploads allow backups, forks, merging. Death becomes elective. Moral circles expand, rights for uplifted animals, digital minds, alien life if found. Long-termism becomes baseline ethics, every decision weighed against billion-year consequences. The galaxy fills slowly, not overnight empire, but fractal expansion, pockets of civilization linked by wormhole analogs or Alcubierre metrics if physics allows, or simply by time-dilated relativistic ships. Dyson swarms encircle stars for energy, but with care, leaving room for natural evolution. We become stewards, not owners, seeding life where it never arose, watching for other filters in nascent biospheres. And the silence? It transforms, not filled with noise, but with meaning. The Fermi paradox dissolves because we become the answer. We are everybody, or the beginning of everybody. The stars that once mocked us with emptiness now reflect our own light back multiplied across light years. Yet even in victory, humility remains. We know how close we came. Every child learns the great filter story, not as myth, but as a warning. We almost joined the silence. We chose not to. That memory keeps us vigilant. Aligned AI monitors for new risks, protocols evolve, expansion pauses if anomalies appear. The final image, a simulated view from a future probe orbiting a terraformed world. Blue oceans, green continents, orbital rings glinting in sunlight, cities of light below. A radio message beams outward, not a desperate cry, but a calm invitation. We made it. Come join us. The voiceover, soft and certain. We asked the stars, where is everybody? They were waiting for someone to pass the test. We did. And now the galaxy is no longer silent. It is listening. A single harmonious pulse echoes, our signal, no longer alone. Fade to infinite stars, alive with possibility.